Hey guys, assuming that you have already finished page 4 in answering all the question, please refer to OneNote for the answer, okay? Then we can move on to the next part already. We are now moving on to page 5. So this is a guide to trigo ratio, okay? You need to learn how to identify it, okay? So what is exactly trigo ratio? Okay, trigo ratio is a ratio that compare different sides of a triangle, and they have a very special meaning to it, okay, which we'll learn along the way. Yeah, so there are three trigo ratios that you'll be learning in this chapter. It's tangent, cosine, and sine. So today you'll be learning these three new things: tangent, cosine, and sine. Okay, and trigo ratio, you must remember before we move on, trigo ratio will only work in what we are learning right now. It will only work in right angle triangle. Don't go and apply it to any triangle that you see. It will only work in right angle triangle. Okay, for the moment at this chapter, we must be able to identify it. So we have a acronym to call it. We call it tuakaso. Okay, I believe you have heard some of your seniors and mention it before. Tuakaso, trigo ratio. But what exactly is tuakaso? Okay, in short, trigo ratio can be put into a fraction form, and we always leave it in the simplest form. So ratio, whenever you hear the word ratio, it's always something compared with something, and then chances are you will get a fraction, right? So it's the same thing here for trigo, just that it is with reference to an angle. Okay, as you've seen just now, if you have a fixed angle, no matter how you change, as long as the angles are fixed, no matter how you change the side length, because it's a similar triangle, your ratio is going to be the same. Okay, and different trigo ratio represent different thing. So the first one that we're learning today is called tangent. Tangent has a ratio of opposite over adjacent. So tangent theta equals to opposite over adjacent. So therefore tangent theta is the angle that you use lah. So TOA, that's why I call it tua. Okay, tuakaso, opposite over adjacent. Then the second one is cosine over adjacent. So this is cosine theta over A equals to A over H. So a CAH. Okay, whereas the last one, sine theta equals to O over H, opposite over hypotenuse. So is so. Okay, so that's what you get here. These are the three sides. Okay, so tuakaso over here, you get the sides right here. Okay, so the reference angle can be PRQ that we see here. You memorize this first, okay? You need to know that they are tuakaso. So now let's move on to the next part. The reference angle, let's say we choose PRQ as a reference angle. That means it's here. Can you label together with me? I think I use red pen, easier to see. This is my reference angle, and then I need to label all the sides. Which one is H, which one is O, which one is A. Okay, this is H, this is O, this is A. Okay, what if in the exact same triangle I change my reference angle now to RPQ? Is this angle. You see the naming of the side changed already. The hypotenuse is the same because it's always opposite of right angle, but now the tree, rather than being an A, this become an O, it is an A. Okay, the reference angle depends on the name of the side depends on the reference angle. The O and A can change. Okay, depends on the reference angle. Okay, right? So I hope you guys are clear with this. So here, why is identifying the reference angle important based on what you learned above? Okay, it's basically a repeat of what I mentioned. Okay, can you copy down? It affects the position of adjacent and opposite sides. And the hypotenuse, on the other hand, remains the same by definition, because it's always opposite the right angle. That's why I say that to apply this, you must make sure that you are looking at the right angle triangle. So therefore, theta is defined as the reference angle, and you get tua, ka, and so, something that we use a lot in this chapter. Okay, what can we find? Okay, here. Now next, what can we find with Pythagoras theorem? Okay, in the past, not in the past, in the previous chapter, chapter 9, you learned about Pythagoras theorem, right? With Pythagoras theorem, which is your a square equals to b square plus c square, where in a right angle triangle, this is your a, this is your b, this is your c, right? What can you find with this? You can find unknown length if you are given two lengths. Okay, which is quite restrictive, right? You can't do anything with Pythagoras theorem unless they give you two sides. However, once you learn trigo, it unlocks more potential now. Okay, you don't need to have two sides. You can find unknown length if you are given one length and one reference angle. If you know one angle and one length, you can find unknown length. Or you can find angle if you are given two lengths. Okay, so you are able to do more now with trigo ratio. You are not so restricted like, oh, I must have more numbers. Okay, no more in that manner already. You can do more now. So let's look at the next part. You need to learn tangent, sine, and cosine are the notation of the trigo ratio, and it is the ratio of the sides of a right angle triangle. Okay, highlight this. It is always referencing to the right angle triangle. Okay, so in summary, TOA, tua, CAH, ka, and SOH, so. So in trigo ratio today, you learn new thing called the tua, ka, so. Okay, so example 1, let's go down to some calculation and see how we do it. Okay, in example 1, for the right angle triangle PQR, you need to find sine P. So let's try. Sine P is equals to QR right here. This is a triangle. If I sine P means I use this reference angle. Can you follow me? If I use this reference angle right here, use pencil, okay, because later we need to change. This is HO and A. So if the question wants us to find sine P, it will be equals to RQ over PR. Okay, which is supposed to be your O over H. Okay, it's supposed to be O over H. So this is 3 over 5. Okay, now part 2, cosine P. I'm still using the same reference angle. Okay, you look at your diagram on the worksheet, cosine P. Can you try to fill up first? If you name the sides, what would it be called? This, wrong color. This is A over H, right? So what would it be called if you name the sides? Cosine P will be PQ over PR, which is 4 over 5. So that's the answer. Leave it in fraction. Okay, so that's what it means by finding the trigo ratio. Okay, whereas for cosine, then you don't need to find an angle, you are just finding the ratio. So next one, tangent P is equals to what? I'm still using the same angle. So looking at the same angle, tangent P is equals to O over A. And here, O over A is QR over PQ. It is 3 over 4. Then, when it comes to the next part, I'm no longer using P as a reference angle. I'm using R as a reference angle now. Okay, pay attention. R is my reference angle. So, my O and A swap. Okay, so it changes. So, next part, part 4. Sine R, what is it equals to? It will be PQ over PR. The PR remains unchanged because the hypotenuse is fixed, right? is a longer side and is always opposite my 90 degree. Then as for the next one here is RQ over PR. This will be 3 over 5. And the last one, tangent R is equals to PQ over QR, which will get us 4 over 3. Okay, so this is how we find the trigo ratios. And take note, don't give unit because they are ratio and therefore they do not carry any units. Okay. Alright, so I hope you guys are done copying. So we'll continue the next part in subsequent lesson. Okay, so that's all for this video.